Okay, so good afternoon, everyone. Welcome to APNIC e-learning web class. Every Wednesday, we conduct e-learning sessions for free to members of the internet community, and we usually have three different topics. Now, this is the third of the sessions that we are holding for today, so it's the last one. Today is the 30th of March in 25th. It should be 2016. Sorry about the date. And it's 3 o'clock in the afternoon from Brisbane in Australia where I'm doing this class. Now, before we proceed with the contents of this session, I'd just like to take a couple of minutes to introduce myself to you. My name is Sheryl Hermoso. I work as a training officer for APNIC. As you know, APNIC is the Asia Pacific Network Information Center. So hopefully you've heard about us before joining this session. If not, APNIC is the regional internet registry of the Asia Pacific region, essentially. So if you need IP addresses and different number resources, you get them from APNIC. Now we have a training team. We conduct different types of workshops, either face-to-face or e-learning type of sessions. And our topics vary. They're all internet related, of course. We do network security, IPv6, DNS and DNSSEC, internet resource management, as well as routing, BGP, MPLS, and all of those things. Now, this e-learning session will run for 1 hour. As I've said earlier, I really do encourage that you participate in the class by asking questions or maybe just writing down your comments or views about the topics that we are doing. And you can do that using the chat. Now, at the end of this 1 hour session, I will be asking you to fill in a survey. The link will be at the end of this presentation. And please take just a few minutes to fill in that form. It's very easy. And it's important for us to gauge whether this is effective. If we can do something to make this more effective for everyone, then we will try our very best. All right. Now, with that out of the way, let's talk about what you've come here for, which is RPKI. So these are the things that we will be covering, right? Unfortunately, we cannot go to the details of the technology itself. We will try as much as we can. But the idea here is for us to get acquainted with what exactly is RPKI, look at the kind of like a bit of a history and how it came to be, what are the reasons why we need it, and what are the advantages that we can get out of it. Now, once we have established that, we will look at how we can implement that, and it starts with the rights to resources, okay? And what are the different components that comprises the RPKI system. We'll look at the APNIC side of it. So from an RIR point of view, what can we do to help this case? So that is going through resource certification. And you as an APNIC member or as a resource holder, you can generate what we call as a route origin authorizations or ROA records, using resource certification, and that how to go about it, we will discuss as we go on. So that's our plan. We only have 1 hour, so let's begin. So first of all, just would like you to know about this working group in the IETF, the Internet Engineering Task Force, has different working groups that pretty much work on different facets of internet technology. This one is about securing the inter-domain routing. So basically layer 3, you want to secure routing, Why? Because routing in itself, say BGP or any other forms of routing protocols, at the very beginning, when you look at their protocols, their specifications, they don't have any security in place. It is considered as a very trustful system. Just consider BGP, for example. You set up BGP, you configure your router, and if there is any BGP speaker that is directly connected to your router, you will establish connection and you will exchange routes. That's how you access the rest of the internet, right? You need to have a list of all the, well, not all, but as much as possible, as many as you can, list of all the routes, IP addresses, IP address prefixes, so that your router knows how to forward a packet that's coming in. So for example, I have a packet, incoming packet, that is directed for apnic.net, right? And apnic.net possibly have an IP address 203.176.189.2, for example, right? So what happens there is your router will have to look at its routing table and then know which of its uplinks, which of its maybe neighbors you will forward the packet into. So what if someone announces a bogus prefix? Have you ever thought of that? So the purpose of SIDR, Secure Interdomain Routing, is to look for ways and opportunities and come up with specifications to reduce vulnerabilities to the interdomain routing system. So two main things that they are looking at is these two questions. Is an autonomous system authorized to originate an IP address prefix? Okay, if I have an IP address block, can I announce this from this network, from this AS? Okay, the second question there is the AS path represented in the route the same as the path through which the NLRI has traveled? Okay, so what does that exactly mean? So your route, your packet will have to go through different routers before it reaches its destination. That is sometimes what we call as the path. Okay, in your route entries, you will have what we call as an AS path, which essentially gives you a direction of how you can reach a certain destination the fastest possible way. Maybe it will have to hop through 5 different routers, 5 different networks. Okay, and these networks are represented by an autonomous system number or ASN. So you'll have there a list of AS numbers that you'll have to hop through to get to the destination. That is your AS path. So the question that they try to answer here is, how sure are we that you're actually going through the right path to get to the destination? What if, for example, I am in Australia at the moment, I just need to send a packet from Brisbane going to, say, a network in Sydney. Okay? Obviously, the fastest way is for my packet to go directly, say, from Brisbane, maybe 1 or 2 hops going to Sydney. What if it passes through, say, somewhere in Europe before going back? Is that a trustful? Is that a reliable path? Right? So those are the two things that it's working on. So the project that tries to answer those vulnerabilities would be public key infrastructure. So I think that's something that you have heard a lot these days. Things like using digital certificates for your websites and things like that. That's PKI, public key infrastructure. Now for routing specifically, you have RPKI. Now this one is new, right? So for most of us, this is a very new technology. That's resource public key infrastructure. And at the end of it, the goal is to have something called BGPSEC, BGP security. So on layer 3, right? So for your routing protocols, BGP, as I've said, it doesn't really have any security in place aside from those add-ons that have been added later on in the specifications. But this one is, the idea is to have security built in specifically for this, for your BGP routing protocols. Now we will not go through that, okay? That is still a long way to go. Right now, this is seen as becoming like an extension to the current BGP to provide improved security for routing, BGP routing, right? It's now an internet draft in IETF, but with all standards, it actually takes time. It takes time to standardize something. It will have to be discussed by the community, and once it's implemented, all vendors, manufacturers will need some time to actually implement it into their devices. So the idea here is this to be implemented using a path attribute in BGP, but there's actually 2 parts into it, right? So BGP prefix origin validation. So if you remember the vulnerabilities in the previous slide, the first vulnerability there is it really coming from the right source? Is it being, say, announced by the correct network or by the correct autonomous system? So that can be achieved using this, BGP prefix origin validation. You're looking at the origin if it's actually originating from the correct or reliable source. And that can be achieved with RPKI. Now later on, okay, once we have established RPKI, the second path to BGPSEC is BGP path validation, which kind of like looks at the second vulnerability or second issue in the previous slide. Okay, is it going through the correct path? Now, we're a very long way to go with that second part. So as of now, the main focus would be on RPKI. So 3 pieces to completing this. The first one is RPKI. Okay, we will of course discuss this in more detail, but in a short explanation, RPKI is basically an infrastructure. Okay, it's a combination of protocols and different organizations. You can generate certificates and all that that can support, okay, origin validation. Okay, RPKI is the infrastructure underneath origin validation. Once you have the RPKI infrastructure in place, you use that protocol to detect any types of maybe misorigination or maybe hijacking of someone else's prefixes. Okay, as I've said, the next part there to complete the system will be AS path validation, which is the culmination of BGPSEC, but it's still a long way to go before that. All right, so what exactly is RPKI? So RPKI stands for Resource Public Key Infrastructure. Now, if you notice, it kind of gets some idea from the original PKI, Public Key Infrastructure. Now, what do we know about PKI? In a PKI system, okay, we're using something that would vouch for the authenticity of say a company or an individual. Let's say you want to set up just a simple website, right? And you want your customers to know, okay, that they're actually on the correct website. What do? You'll have a digital certificate. Where do you get those digital certificates? From a certificate authority or CA. Okay, so it's kind of like an infrastructure, a system that verifies the identity of an individual or an organization. So in a kind of like similar way, okay, the purpose of RPKI is to, okay, have a system or an infrastructure in place that can be used to verify that all your prefix announcements are correct and they're coming from the right source. Does that make sense? Okay, you have an infrastructure that you can check with, okay, to know whether the prefixes that you have on your routing table are actually coming from the correct origin. Therefore, origin validation. Okay, so it's a robust security framework for verifying the association between resource holder and their internet resources. So what exactly is a resource holder and an internet resource? When we say internet resource in this case, it's about a number of resources. You say IP address, IPv4 blocks, IPv6 blocks, and even AS numbers, autonomous system numbers. Those are your number resources. That's what we're referring to here. Now, resource holders are organizations, okay, that now hold these IP address blocks. So, for example, you are an APNIC member, right? Where do you get your IP addresses? Maybe it's coming from APNIC. Maybe in some cases, you might get a small block from your upstream providers. So you have an IP address block. Now, this is, okay, this is kind of like something that has been leased to you. So you're the only one who should be announcing that block. You should be the only one who should be using an IP addresses out of that block. Remember? Because it's a public space and no two networks, no two, say, devices should have the same public IP address. Is that right? So here, what we're doing is you have a block. Say, for example, 2406.6400/32. Okay, that is the block assigned to APNIC training team. So I will be announcing that to the global routing table. That's the purpose, right? You have to announce your prefix so that traffic will come to you. Okay, you will announce it to your neighbors. Your neighbors will announce it forward to their other neighbors, so it is propagated. Now you are the resource holder. The resource here that we're talking about, okay, the number resource is the IPv6 2406.6400/32. So how can we now, okay, connect those two? Okay, how can we connect those two? Let's have a look at this. Okay, let's just complete this one. Basically, it helps us secure the internet routing by validating different routes. Okay, how are we going to do that? So, these are the different RFCs and RPKI. Okay, let's just go through this before answering that question. Now, RPKI is not exactly a very new thing, right? It's been around actually for a while, and it wasn't usually called as RPKI. Now, the current standard that we have is RFC 6810 and that range. So the RPKI infrastructure is the standard itself is defined in RFC 6810. That's RPKI, the routing protocol. There is a comment there. Okay, logging in with username and password. All right, that's a good thing to do. I'm gonna have to check with our team whether we have other issues like that. But I'm glad that you were able to join using the chat. Hopefully others are not stuck with trying to use their password. Anyway, so going back to this again, this is for you to have a look at your spare time. So we'll just leave it like this. If you have time after this and you still want to learn more about RPKI, about say the RPKI to router protocol or the infrastructure itself, how it's done, what are the different supported say repository, how it's connected and things like that, you can have a look at these RFCs. And this is the history behind that. Say, as I've said, it's not exactly new. In the early 2000s, it's called SPGP. It's a little bit different, but the idea is kind of the same. It's secure BGP. They even had some workshops around secure BGP. But right now, it's the protocol that is being done or being standardized is what we call as RPKI. You can find some examples of this in rpki.net. It's an open testbed that you can have a look at, you can download. But before you go to that, let's try to understand the different components so you know what exactly you're doing when you download the code that you can get from rpki.net. So what is the purpose of RPKI then? So I think by now it's kind of clear. What we want to do with RPKI is to map the resource and the resource holder. Why? When you have the resource and you know that it's coming from the right source, okay, you can prevent these two things. You can prevent route hijacking. So in say route hijacking, a prefix, okay, is announced or originated by someone else. Let's say you have your own IP address block, right? But for some reason, someone on the internet announced that IP address block. Okay, this has happened before. This is continuously happening. The reasons may vary though. So if it's malicious in an intent, it's called route hijacking. They did it on purpose. Okay, they want, let's say, they want some prefixes. Sorry, they want traffic to go their way. Let's say, for example, there is a popular website and you want to steal some of that traffic. Okay, so maybe you'll run some ads, you run some things on your own website that you want that redirected. One thing that you can do is, of course, announce that same IP address block so some of the traffic will go your way. That's malicious, so we call it as route hijacking. Now, the thing is, in most cases, this happens as a, like, not exactly malicious in intent, but it's a mistake. Maybe someone is configuring something and through fat finger, he typed in the IP address that is not his. Very similar, but maybe just different in one digit. Okay, but it's still a different IP address block. So it's wrong. Okay, it's a mistake on the administrator's part. Okay, so you have mistakenly announced someone else's IP address block. So that's what we call as misoriginated. So either way, whether it's malicious with route hijacking, whether it's a mistake, with misorigination, the effect is the same. You will have some traffic redirected your way, okay, and stealing some of that bandwidth and traffic from the original or the supposed to originator of that prefix. Okay, so now the question is, so you know what's the purpose, but how can we implement that? We use RPKI. With RPKI, you map the resource with the resource holder. The resource is your IP addresses, V4 and V6. The resource holder could be, okay, the AS number, right? So you're tying up the IP address and the IS number. So you know that for 203.176.189.0, say /24 block, it should be announced by AS17862. Okay, so you can check your route entries. Is this block originated from this AS number? If it is, then it should be indicated as such. If not, then you will also have an indicator that says this has not been validated. And how we can achieve that is by using certificates. Remember, in the typical public key infrastructure, we have X.509 certificate, right? So we're using the same certificate, but it's extended. It's called 3779 extension. You have something on this certificate that will hold, okay, the list of resources, the IP addresses, and the corresponding AS number that is supposed to announce that IP address block. So it's now part of your certificate. Obviously, it will still have other information such as SIA, subject information access. It will have information about yourselves, the owner, the public and private keys, and things like that will also be generated using this certificate, right? The only difference is there is an additional block, okay, or additional field that contains your IP address and your AS number. So what we're proving here is the right to resource. The way that IP address blocks are distributed is like this. You have IANA, or the Internet Assigned Numbers Authority. The IP address blocks are distributed to what we call as regional internet registries, or RIRs. We have 5 RIRs in the world. One of that is APNIC. Now, if you are a local internet registry, maybe you're an ISP, or maybe you're an enterprise network, you want to get a portable IP address, you get that from your RIR. So LIR, local internet registry, gets their IP address resource from the RIR, the regional internet registry such as APNIC. Now, once you have your IP address block, right, you announce that. You tell your upstream providers what portable IP addresses do you have so that they can announce in your behalf and traffic will come your way. Now, if you are the upstream provider, what do you have to do? If a local internet registry comes to you and tells you, can you please announce my prefix? This is my IP address block. What do? You have to do an LOA check, legitimacy of address check. You have to check whether they are legitimately supposed to be announcing that IP address prefix. Okay? Otherwise, all announcements coming from your customer, that LIR, should not be allowed going out, right? So if there is somehow a mistake on my end, I suddenly announce this prefix, but I'm not supposed to. My upstream provider, they have some filters in place, route filtering, so that traffic going that way will not be allowed. It will not be announced anymore, right? So that's your right to resources. We need to be able to authoritatively prove who owns an IP address prefix and what AS numbers or networks may announce that block. So we're just connecting IP address and AS number. Any questions for now? So that's the concept behind it. So I hope that's clear, okay, what we're trying to achieve with RPKI. Now, there are 2 components to RPKI. This is how we can implement this. We have to understand the infrastructure because it's not just a single device or single software that you have to enable and you're done. Okay, it relies on an infrastructure. So there are 2 main components here. If you remember, in the typical PKI system, you have certificate authorities or CAs. You get your certificates from the CA, right, to vouch for your authenticity, right? Now, in RPKI, you also have what we call as certificate authorities, okay? But these are not your typical third parties, global CAs, okay, that are running independently. Generally, this will be your internet registries, the RIRs, such as APNIC. If you have national internet registries in your economy, they can also act as a CA. If you have very large LIRs, then they can also set up a system where they are acting as a certificate authority. So what they do is essentially to issue certificates to the customers using what we call as ROAs. So they issue ROAs for the prefixes, and that ROA contains the mapping that we've talked about, the IP address to AS number. Now, the other half of the RPKI system will be the RP, or relying party. So this is a software which gathers data from the CA. So what happens is like this, right? You have CAs. So your CAs right now will be your RIRs. These RIRs, the moment that they generate ROAs for their customers, okay, for APNIC members who have portable addresses, once they've issued ROAs, it will be published in a repository, right? Now, there are many repositories for each RIR. So the purpose of a relying party is to gather all of these coming from different repositories, right? So from there, you can connect your router. That router should, of course, understand RPKI so that it can validate prefixes using the relying party. So let's look at that in more detail. So the first one, these are your CAs. It is also called as the issuing party. Okay, again, it acts as your CA. It issues certificate to customers. Now, the way that this is done is usually like this. So for APNIC, for example, we can actually generate ROAs, okay, by logging into MyAPNIC. MyAPNIC is a portal for members. So once you log into MyAPNIC, you can go to the RPKI engine, enable the RPKI engine, meaning that you're using APNIC's RPKI, and then choose the IP blocks, the maximum length of the block that you want to announce, and the corresponding AS number that will be used to announce that block. Okay, so you create your ROA. So that's the form that you can see here. It's not very clear here, but once you download this, you can zoom in. Or if you have a MyAPNIC account, try and log into that, and then try this. Look at this part, right? So it will be published using the repository at rpki.apnic.net. So again, it's not just APNIC. LACNIC, RIPE-NCC, AFRINIC, ARIN, all the other RIRs will have their own repository. So you'll see there rpki.arin.net. So that's another repository. Big NIRs and LIRs could possibly have their own repositories as well. Right? So the purpose of the issuing party is, okay, to allow users to generate their own records, ROA records, and then publish these records in a repository. Now, the next part there is your RP, your relying party. As I've said, the main purpose of an RP is to gather. Okay, so from all of these repositories that you can find here, it will gather all of those data, okay, all of those ROA records, and put it here. From there, it will publish a list of all the validated cache. So it can be most of the time right now it's mostly software. Okay, so it's a software that gathers data from your CAs. Sometimes you also call it as an RP cache. So I think you actually will hear it more as an RP cache or an RP validator. So how can you have this? There are many open source available that you can download. Right now, if you go to rpki.net, they have an open source software that can do both as a CA and as an RP cache. So if you want to implement this and test it, go over there and download it. It also has information about this, pretty much the steps that you need to follow to install it into your, say, Ubuntu machine. Okay, and then now once you have that, by the way, there are also available RP caches, but mostly in their test phases. So if you cannot set up your own RP cache, you can always connect to one of those public RP caches. But again, they are still, most of them are still in the testing phase. All right, so once you have that, okay, I don't have a slide, but this is the next phase. You have this router. That router should be running an OS version that has support for RPKI, so that it can run what we call as RPKI to router protocol. Okay, now what happens there? You have to, of course, configure your router, but it will give you information about the routes that it has received. So if, let's say, normally in your router, you receive the full routes. You receive all, let's say, say, maybe just a small amount, maybe 10,000, okay, 10,000 prefixes. It will be in your routing table. But aside from the typical information that you get on your routing table, which has all the attributes, information about the AS path, information about the origin, and things like that, the next hop, you also have the BGP states. It will have a column that says whether an entry, okay, a route entry is valid, invalid, or unknown. So what are these BGP states? So valid is if there is a matching VRP that was found. So your router connects to the RP cache to get those VRPs. So that's basically validated row-up payloads, VRPs. So when you say validated, okay, that only means that this IP address block, okay, is announced by this AS number, and there is a matching, okay, row record in the RP cache. Okay, so you have an entry, you have an IP address, you have an AS number. You check that with the RP cache. The RP cache will tell you that, oh yeah, it matches because I have an entry here, I have a row record here that says the same thing, that for this IP address block, it should be announced by this AS number, which matches to what you have. That is when you get a valid state. Now, the other one is invalid. If you have a VRP, let's say you checked for the block 2406640/32, okay? I checked the RP cache. Oh, there is a VRP for this IP address block. However, what is in the RP cache, okay, is different than the originating AS number that you have in your routing table. So the AS number actually did not match. So if that's the case, the state will be invalid. Now this last one here is unknown. Now I think if you set up RPKI right at this moment, okay, a lot of your entries, your routing prefixes will have this state, unknown. Why? Because first and foremost, not everyone has generated the row records. Okay, so if, let's say, I got a route prefix in my routing table, I check with the RP cache. The RPKI cache would say, I don't have an entry, I don't have a VRP for that IP address block. So what do? The state will then be unknown. So these are the three different states that will be added onto your routing table. For each of the entry, for each of the route prefix, you'll have information whether this route prefix is valid, okay? Then you have to trust it, right? You can trust it because you know that it's actually originated from the right source. You have checked the RP cache, you have checked a valid source, okay, that says that your prefix is actually originated by the correct AS number. Okay, so you have more trust in that. The other one is if you receive an invalid. So there is reason for you to doubt whether, hang on, this block is announced by this AS number. Can I trust this? It doesn't seem to match with what is in the RP cache. So there's reason to doubt. Maybe the next step for you is to verify with the source. Okay, maybe it's one of your customers, and then you can check whether there was just a mistake with the configuration and things like that. Or maybe they haven't updated, okay, their record. Maybe they move that to another ACE number, announced by another ACE number, but they haven't updated the ROA record, right? Again, most of the time you'll see unknown, okay? Possibly right now, maybe less than 10% of all the route prefixes will have ROA records for that. So any questions? That's how you implement RPKI. You need at least three different components. You'll need your say your RIR or your LIR to become a CA, okay, to generate the ROA records, okay, for you. And then you need an RP cache. Your RP cache may be something that you implement yourself, or maybe something that's available over the internet that you can connect to. And then you use that, configure your router that is enabled with RPKI, that can understand RPKI, and then use that RP cache, connect to that RP cache to do your validation. Now let's look at the first one, which is for the CAs. So as I've said, who will be acting as certificate authorities will be your RIRs. Okay, not any third-party certificate authorities as such. So in APNIC, we have a program called Resource Certification. So through this, okay, this is an initiative from APNIC aimed at helping out with this purpose to improve the security of the inter-domain routing and to augment the information that is published in the WHOIS database. The WHOIS database, by the way, is a public resource. So it's a public database where you can check, okay, different, say, what we call as objects, which contains information about those IP resources. So when you say LOA check earlier, legitimacy of address, you can actually check with the WHOIS database, see whether for this IP address, it's being announced, or not being announced, it's actually owned by this, say, this company. If this company is the one that's holding that resource, you can check that with the WHOIS database. That's a very manual process, right? So that's one thing that you can do to kind of protect routing. Of course, RPKI is here to have a more systematic, okay, and automated way of doing this. So in here, the APNIC will have like a system where you can do this. That's resource certification. You're using or you're generating ROAs, or route origin authorization. So what's an ROA? I keep telling you about ROAs. You should have ROAs. It's just basically an object, right? It's a digital object that contains a list of address prefixes and a single ACE number. So you can have 1, 2, or more IP address blocks and just a single ACE number. So you're proving that this resource, this IP address block, or these IP address blocks, they are to be announced or originated by this network, which is represented by this AS number, right? It is an authority created by a prefix holder to authorize an ASN to originate one or more specific route advertisements. Now you have to create these yourselves using MyAPNIC. So I do encourage you to start doing this. Even if the plan to implement RPKI on your routers is still a while, I think the very first step that you can do is, of course, one, to try to understand what exactly is RPKI, which is the reason that you're here. And the second would be to start creating your ROAs. So publish your ROA records using MyAPNIC. You can simply log in to MyAPNIC. Okay, we just skip that. So, and then it's not very clear from here, but APNIC CA will be here. You can use MyAPNIC to access that engine. Then through the RPKI engine, it will be published in a repository. These repository, you have sync access. You can sync your RP caches through this, right? So you start with MyAPNIC. You have web access to MyAPNIC. Generate your ROA records. It will be added to the what they call it, to the repository, and will be accessible to the rest of the RP cache. it is something like this, right? Once inside MyAPNIC, this is what you find. We just changed the MyAPNIC interface earlier in February, so I haven't really updated the slides yet to show you the actual screenshot, but the idea is the same. You have there under resources, you have certification. You can enable resource certification. So you're saying that you want to operate in the MyAPNIC RPKI portal. If you are creating your own RPKI engine, of course, you'll select the second one. But 90% of the time, APNIC members would go for the first option. Operate MyAPNIC RPKI portal. Okay. Now, to be able to get to this, it's not available to just anyone who has MyAPNIC access. Usually, you should have certain privileges, and you should have digital certificate installed to see this. So if you're having issues just looking at the RPKI engine, it's not showing up in your case, just give us a call, talk to our help desk team, and they'll be able to help you out with that. Now, once you've done that, you create your row object. So it's a very easy interface, really, okay, as long as you understand what you're doing. What you want is for a certain IP address block to be announced by or originated by an AS number. So in this case, I have AS12345. Okay, this is dummy, of course. This is just an example. And then the prefix will be this. This is my block. Okay, I have a list of my blocks in my network, so it should show up automatically for my account, and then you just choose which one you're going to use. Let's say, for example, here you have a /23 block, but you only want half of it, which is your /24. You only want that /24 to be originated by AS12345. So you can do that. It doesn't have to be the entire IP address block. Let's say you have a /19, but you've subdivided that /19 to, say, different customers. So it's announced by different AS number. So you can just say that only from this /19, only this first /24 will be originated by this AS number. You add that, and then you commit. Okay, you add, and then you commit for this to take effect. Under APNIC for RPKI, it's permission denied. Who will help me on that? Okay, that means you don't have any permission. One possible reason is because you don't have digital certificate installed or you don't have TOTP. So just check your account first. Okay, if on the browser that you're using, you have digital certificate. Okay, it's either or. You have digital certificate or you have set up two-factor authentication, TOTP. So check that one. Now, if you're still having issues, maybe it's a permission on your account, which might need to be elevated. Say your corporate contact didn't give you permission to do these things on your network. So it's just say maybe you're just a technical contact. Okay, so well, but you can check with APNIC through our help desk team, so we can have a look at your account. All right. Any other questions? Okay, that's good. That's good. Abhishek has tried it. So for all of you, if you have access to your MyAPNIC, you can do it now. Just try to log into MyAPNIC. Look at the certification part. Okay, it's under resources, and somewhere down at the bottom right side, you should see the RPKI, and click there. It might show, yeah, permission denied if you're not allowed to use it, or you don't have a digital certificate, or it should show you an RPKI engine that you can enable yourselves. Okay, so the next stage for you is, of course, to create your ROA. Okay, create ROA using this form. Put in your origin AS number and the prefix, and importantly, you can also provide the maximum length out of this prefix that will be using that AS number. Okay, you can also delete ROAs at any time. Okay, that's not something that, like, once you've created, it's there forever. You can always delete it. Maybe there are changes. Maybe you want this block to be announced by another AS number. Then you can always do that. Simply delete, okay, using, say, that icon on the side here, and then commit so that will take effect. All right, so at APNIC, we have this program called Ready to ROA. So you might see some of our staff when we're attending different conferences and events, maybe a NOG event. Some of us will be encouraging you to create your ROA. So we have set up different ROA sessions to this event so that you can outright on that event explore resource certification, maybe on the spot create your ROA records if it's possible in your case. For more information about that, you can check apnic.net/ROA, okay, to learn more about it. Of course, we've already tackled quite a lot here, but specifically for resource certification that's done in Myopinon, you can have a look at this link. Now, any other questions that are not clear to you regarding this, if you want to create your ROA, okay, again, I encourage you to do that. If you're having any issues, please feel free to let us know so you can help you out with that. Okay? All right, so I think I have a few more slides here, which is pretty much for us technical engineers who wants to play around, maybe explore RPKI. Now, right now, at this moment, you are encouraged to experiment, maybe test a little bit, play around with it, develop the RPKI, say cache and things like that, but not exactly to have it in production, right? When you have the RPKI in place, say on your router, it gives you an indication, but it doesn't exactly do anything. It's status, okay? But it's not like once you enable that on your router, it doesn't mean that all blocks that are invalid or unknown will be automatically filtered out. It's not like that, okay? It's a status, and it is now up to you to maybe create filters or create prioritization based on the output that is given to you. Okay, so right now you're encouraged to kind of look into it, maybe implement it, maybe read a little bit more about RPKI and how to implement it in more detail. Look at the links that I've told you about, maybe install an RP cache, okay? Maybe look at if your routers are not upgraded yet and you are, say, in the, you have a schedule to update it in the next year. Maybe that's something that you can add in your specifications, support for RPKI, okay, so that you have a system in place that they can test all of these. So you can give that a try, okay. Again, the steps for you would be, first of all, create your row record. Once you have done that, look at rpki.net, and there are 2 or 3 others out there that are free. You can download, you can implement your RP cache. If you want to develop something in-house, you can also look at that. Just check the specifications, check the standard, okay, and then install that. You now have an RP cache. The next stage is for you to have a router, have support for RPKI, connect that router to your RP cache, and then look at the output. From there, okay, you can now set different priorities. Maybe you can give more priority to those valid prefixes over invalid or unknown prefixes. Maybe you can say if it's invalid prefix, if you want to be strict about it, you can filter out or block traffic that's coming from those that are found to be invalid, right? But again, as of this moment, the best thing for you to do is just test it out. Don't implement these things into production yet, right? So any other questions from the chat? It looks very quiet, but yeah, it's good that I have some people typing in some things on the chat. But if you don't have any more questions, please feel free to click the link to answer the feedback form, and the slide handouts are also available that you can download. I think I'll just type in the link there because I'm not very sure whether you will be redirected. This is the link where you can download the PDF copy of the slides that we did for today. So 3 different ones, so you can review it on your spare time. Again, if you have anything further to ask later on, please feel free to send me an email. My email address is on the slides. RPKI is only a complement to WHOIS. Can I say that? As WHOIS is only the database, but RPKI will be the enforcement. So it's kind of like a different engine. They're achieving different portions. There's kind of like an overlap, but they're achieving different portions of securing your routing, right? with the host database, you can use that for what we call as Internet Routing Registry, or IRR. So many network operators are actually basing their filters on the IRR. They will check the routing registry before, say, and then set up filters in place. So in a way, that's very similar to what we want with RPKI, right? But in this case, the problem really is with the current quiz database, there are so many objects there, and we're trying so hard to clean that up. Some of the objects there are not quite updated, and it's hard to ask people, ask the operators, ask the owners of the objects to keep those objects updated. So you can use that. You can still continue using Internet Routing Registry, but another way to provide that form of security for routing is through RPKI. It's not exactly a complement to WHOIS because the implementation is very different. It's not relying on the WHOIS objects to begin with. You're creating new objects called ROAs in this case. They are in a different repository, but the purpose is there is an overlap in the purpose. Okay, one of the early ways that we're still using to secure routing, secure BGP, is actually to use Internet Routing Registry. Okay, so if you're already implementing IRR, please go ahead and still use it. Okay, if you want to explore how RPKI can help with your BGP security, then go ahead and play around with it as well. Does that answer your question, Adrian? Okay, that's very good to know. If you have any further ones, please just write them down. Any other questions or clarifications from everyone here? If not, again, create your ROA records, do Ready to ROA, and please register to other e-learning sessions in the future. So bye for now, and I'll see you another time. Bye-bye.